Now today for reaction kinetics, let's look at understanding the rate equation. So in JC, you have to understand that all the reaction, how fast the reaction proceeds is governed by something called a rate equation. It is a mathematical equation that you can calculate to see how fast the reaction proceeds. Now in secondary school, you have learned about several qualitative factors that affects the rate of reaction. For example, you will know that temperature will affect the rate of reaction. You'll know that catalysts will affect the rate of reaction. You'll learn that maybe the size of particle will affect the rate of reaction, and lastly, maybe the concentration. Okay, how concentrated your solution is. The more concentrated it is, the faster your rate of reaction. Now in JC, all of that factors is governed by a mathematical equation known as the rate equation. So let me take you through them. We have your rate. Okay, your rate is affected by something called the rate constant. K is your rate constant. Okay, multiplied by the concentration of the reactant raised to the power of something called an order of reaction. Now, so this is the rate equation. I will just call it, let's say for a reaction A to B, A to power of N. Now, how do these qualitative factors tie in with your rate equation? So very obviously your concentration term is over here. Your concentration term is over here. Okay, the higher the concentration, the greater your rate. Okay, assuming of course that your N is not 0. Now, how about your temperature, your catalyst, and your size of particle? How does it affect your rate equation? Okay, they are actually governed by something called your rate constant. Your rate constant is given by this equation, rate equals to A, E minus EA over RT. Okay, so your temperature is over here. Your catalyst will affect your activation energy, and your size of particle is over here in your A term. A is just a pre-exponential term, it's just a constant. Okay, so all these factors, a higher temperature will cause your rate constant to increase, and therefore it will cause your rate to increase. A catalyst will cause the EA to decrease, and therefore your rate constant to increase, and therefore your rate will increase as well. Now, what about the order of reaction? This order of reaction is found by doing experiments. We will talk more about this in the next video series. It's found by doing experiments, and it's not by looking at your stoichiometric overall equation. In other words, an equation like this could have a rate equation that is dependent on A and B squared. It has nothing, okay, I repeat, it has nothing to do with the coefficient here. Okay, sometimes it could be the same, sometimes it could be different, and that would just be a coincidence. The order of reaction must be found from the experimental methods. Okay, we will discuss more about this in the next series where we'll be looking at the reaction mechanism. Okay, and this is 1 minute of chemistry. See you the next time.